Alright guys, we're talking more about congruent triangles, and we're going to add one more piece to the proof that, or the proofs that we've been doing. So the first thing I want you to do is try on your own to fill this out. If we know that triangle KFG is congruent to triangle KHG, then we know that all of the parts of that triangle have to be congruent to each other, meaning that all of the sides that match up are congruent, all of the angles that match up are congruent. If you need to peek, there's a picture on the other side of your page on the notes, but try to fill these in. So pause the video right now, try to fill them in. I'm going to fill them in up here right now. So I see sides that match up, and I'm using this statement to get me there. KF is the first two letters of the first side, and then KH are the first two on the second triangle. So then FG is 2 and 3, and HG is 2 and 3. So those match up. And then my only other combination is K to G. So first to third is congruent to K to G. What do you know? Those are the same. Reflexive property. Okay, angles then. I want to be very careful because I can't just say angle K is congruent to angle K, because that means that there's two different angle K's there probably. So I'm going to name it with all three letters. So if I'm putting K in the middle, then I'm just going to do like second letter, first letter, third letter. So angle FKG is congruent to angle HKG. So that's my angle K is congruent to angle K. I just had to be more specific about how I named it. Then if I look at the next one, angle F is congruent to angle H. Since those are different, there's no way to confuse those. And if you peek at that picture, those are the only angles that would be considered F and H. I get to the third letter and it says angle G is congruent to angle G. Again, can't do that. So I'm going to start with the second letter, then go to my vertex of G, and then go to the first letter. So angle FGK is congruent to angle HGK. Hopefully you're able to get those on your own. You could have had those specific ones flipped, like the first set of angles, you could have had GKF and GKH, and then the third set you could have had KGF and KGH. But hopefully you're getting better at matching up those pieces and parts, especially if you have a picture there. So if we know that two triangles are congruent, the reason that we know that all of these are congruent to each other is because corresponding parts of congruent triangles are congruent. You need to know this statement, but I don't expect you to write it out every time if you know what the statement means. So I'm going to take all of the letters that are capitalized and just use those letters. So corresponding parts of congruent triangles are congruent. Somehow come up with a method to help yourself remember CPCTC. So that's our shorthand way of writing corresponding parts of congruent triangles are congruent. Let's see how we would use this. So our proofs are going to start out the same. And there's that triangle that I told you could peek at if you needed to. So our given statement says GK bisects angle FGH and angle FKH. And so our reason is that it's our given statement. Now I'm going to go ahead and go to the bottom here and say FK is congruent to HK. That's my prove statement. So I filled in the pieces. that we have. I'm not going to mark that proof statement in the picture because that's what we're trying to get to. We don't know it yet. That's what we want to show. So you'll notice the line before it says that the two triangles are congruent. So let's ignore line 5 for a little bit, and then nothing really is new. Let's get these two triangles to be congruent to each other. Okay, so my reason for number 2 says definition of an angle bisector. Think back to what an angle bisector is. And so an angle bisector means that we're cutting the angle in half. And it means then that the two angles that result from cutting in half are the same. They're congruent to each other. So I noticed in my given statement it says GK bisects angle FGH. Trace FGH with your pencil. So notice FGH is over here on the right-hand side of your triangle. Then these two angles, by definition, should be congruent to each other. So if I label those angles, I have FGK. So angle FGK is congruent to angle, and then I need to go to the bottom triangle, HGK. And that's one of them that we had written down on the front of our paper. But it also says that GK bisects angle FKH. So if I look at the left-hand side, then these two angles that GK is cutting in half are congruent to each other. So again, if I trace, I have FKG, so angle FKG, and this is still in statement 2. We haven't moved on to statement 3. FKG is congruent to HKG. So angle HKG. By definition of an angle bisector. Okay, now we have statement and reason 3 that are totally empty. So I'm going to go back and look at the picture. I have two pairs of angles marked, but I see that those two triangles are touching right here in the middle. And so those then are going to be congruent to each other. And so we talked about going in the same order. So I noticed that in the top triangle, if I go from 2 arcs to 1 arc, it's in the direction of KG. In the bottom triangle, if I want to go from 2 arcs to 1 arc again, it's also in that order KG. So they haven't flipped the triangle on us this time. So KG is congruent to KG. Our reason is reflexive. It's congruent to itself. And that's property of congruence because we have a congruence symbol there. So now, why can we say the two triangles are congruent? Just like we have been practicing, you look at that picture, I see two angles, the side in between. So our reason is angle, side, angle. Up through line 4, our proof is totally the same as what we've been doing. The only new thing we're doing is line 5. Now that we know the two triangles are congruent, now that we've proven that, we can say that any of the pieces of the triangle are congruent. So FK is congruent to HK, and our reason is because corresponding parts of congruent triangles are congruent. That's all we did was add that one line. Let's try another one. So in this one, our given statement is that AB is congruent to CD and AD is congruent to CB. So I'm going to put given there. And I'm going to go to the bottom and put AB is parallel to CD. We got to determine why that's true. So we only have one more statement to fill out. I noticed that the given statements are not marked, so I'm going to mark them in the picture. So AB and CD are going to get a single tick mark, and then AD and CB are going to get double tick mark. So now I see it's touching by one side. I want you to notice that those triangles have been flipped around. So if I go to the top triangle and go in the order B to D, I'm going from single tick to double tick. If I go to the bottom triangle and want to do the same thing, I'm going to start at point D and go up to point B to make those match. So the triangles got flipped around. but still it's the same side that we're marking, so we call it the reflexive property of congruence, since we're using congruency symbols. All right, now line 3 says triangle ABD is congruent to triangle CDB. Why can we say that's true? If you look at the picture, we have 3 sides marked, so our reason would be side, side, side. Now, why can we say that triangle ABD is congruent to triangles, or ABD is congruent to triangle CDB? Well, because we know that all of the corresponding parts of congruent triangles are congruent. But we said that was our next line, so now we're even taking it a step further from there. So I'm going to mark this in the picture. ABD would be this one up here, and CDB would be this one right here. So now why can we say that AB is congruent to CD? And you got to think all the way back to chapter 3 here. Those angles are on opposite sides of a transversal. They're on the inside. So those are alternate interior angles. But we're proving it's parallel, so that's the converse theorem. Okay, so we'll practice more of these proofs in class. Come see me if you have any questions.